In this video, we're going to divide monomials by other monomials and use the rules of exponents and fractions to simplify each. Before we get started, recall that a monomial is simply a polynomial with one term. So if we look at this first example, we have negative 12x to the fifth, that's a monomial, and then it's divided by 3x to the fourth, which is another monomial. For each of these examples, I'll show two approaches. The first approach is simply canceling factors that are present in both the numerator and denominator. And the second is to use the rule of exponents for division, which gives us, let me summarize that rule real quick, a to the m over a to the n is a to the m minus n, so that when we have the same base, we subtract the exponents. So with this first one, negative 12x to the fifth over 3x to the fourth. The important thing here is that x to the fifth in the numerator has a higher degree than the variable expression in the denominator. So we should be left with a variable expression in our numerator when this is simplified. So if we look at this just in terms of canceling, negative 12 and 3 have 3 as a factor. So I'm going to write this as negative 4 times 3, and then I've got 3 in the denominator, and then x to the fifth and x to the fourth. They each have x to the fourth as a factor. So I'm actually going to write this as x times x to the fourth in the numerator, and then in the denominator I'll write x to the fourth. And the reason I'm writing it this way is that now I can see that these factors of 3 cancel, and these factors of x to the fourth will also cancel. And when everything's canceled out of that denominator, I'm left with a 1. So what I have is negative 4x over 1, which of course is just negative 4x. So looking at that, this canceling process is something that I'll sometimes do in my head. What's shown there is the formal process of what cancels and why. An alternate approach, though, for this particular problem would be to rotely use the rules of exponents. So I'll show an alternate approach here. And if we take negative 12x to the fifth over 3x to the fourth, and we just break that down into negative 12 over 3 times x to the fifth over x to the fourth. The negative 12 over 3 is going to be negative 4, and x to the fifth over x to the fourth is going to be x to the 5 minus 4, which of course is x to the first. So that will simplify to negative 4x to the 1, or just negative 4x. Both of these approaches will get us to the proper simplified expression. They're just slightly different uses of the rules of exponents. So looking at b, we have 12t cubed over 9t. This one will definitely be easier if we just look at canceling. So we know that a factor of, looking at 12 and 9, a factor of 3 will cancel out of the numerator and denominator, and a factor of t will also cancel. So to see what exactly cancels, I'll write that as 4 times 3 times t squared, and that'll be over 3 times t. So I've just broken that down according to the factors that will cancel, and each of the numerator and denominator have a factor of 3, and each of the numerator and denominator have a factor of t. So what I'm left with then is 4t squared over 3. As an alternate, if I want to use the rules of exponents directly, then I'll take that 12t cubed over 9t, and I'll rewrite that as 12 over 9 times t cubed over t. And 12 over 9 will simplify to 4/3, and t cubed over t, I can think of that as t to the 3 minus 1. Again, that exponent on t is simply 1. So I have 4/3 t squared, which of course can be written as 4t squared over 3.